Hello, 8th grade. This is Ms. Willing here, going with our first virtual math lesson. We'll see how this goes, but I do really miss all your faces. Yeah, it's definitely not the same. But here's the deal. I always like to start with where we are in the textbook, where we're headed, what's going on. And so we are in chapter 10 in your textbook. I do hope you all have that textbook at home with you, or if not the actual textbook, you're comfortable accessing the online version of it. We will more than likely have homework in it, but it will also, I think, prove a nice resource for you should you need it. So chapter 10, the title of chapter 10 is Polynomials and Factoring. And I'm basically splitting this unit into two. The first part is going to be definitely the shorter one, and that is just we have to talk about what are polynomials, right? What are they made up of? How they actually have a special way of being named, which we're going to talk about today. But then we're going to spend the next couple of days just playing around with polynomials, simplifying them, right? Just like numbers, polynomials can be added and subtracted and multiplied and even divided, although we won't be doing much with the dividing. So we'll do a little bit of that for the next week or so, and then by next week we'll switch gears and we'll get into the factoring of polynomials. For those of you that are curious and just maybe if you don't have your actual book and are relying on online textbook, chapter 10 starts at about page 568, right around there. Okay, so these slides, I'm going to talk you through these 9 slides of notes that I have, and then I will, afterwards, I will send you a copy of these slides so that you can go back over them at your leisure. You could print them, you could copy them into your notebook, whatever works for you. But for now, I would suggest just kind of sitting back and relaxing and just sort of trying to soak this in, because a lot of this I know you're seeing for the first time. So I wanted to talk it through, but I will also provide you with all of this in a little bit. Okay, so before we can talk about what a polynomial is, we have to talk about what a monomial is. And those of you that are good with your word roots might already know that poly, anything, always means several of something, just like mono always means one of something. So monomial means that you are dealing with a single number, variable, or the product of a number and one or more variables, right? So I have 4 different examples of monomials for you here. A basic number 8 is a monomial, as is the product negative 4x, as is xy squared, as is that big massive chunk of stuff 365x cubed y to the 4th z, right? Because they're all being multiplied. So notice, no addition signs, no subtraction signs. There is a negative sign in front of the 4, but that's just to indicate that it is a negative 4. So all 4 of these are examples of monomials. Please note below, you guys are very familiar with monomials. It's just that I often refer to them as terms. It's the same exact thing, right? Those words are interchangeable. So if you ever were wondering what I meant, all those times I was talking about a specific term, that's what I meant. A number, a variable, or a product or clump of number and variables, okay? So that's what a monomial is. Now, monomials have what we call a degree, and you figure out what the degree of a monomial is by adding the exponents of all of its variables. So in the case of that first example, 4x, its degree is 1 because the variable x is being raised to the first power. Right? We don't care so much about the 4. We just care about the fact that the variable x is being raised to the first power. That's what makes the term 4x have a degree of 1. So for these next 3, I'm going to pause and let you think about it for a little bit, and then I'll reveal. But I'm also just going to talk for a minute to introduce the next one. The monomial xy squared. Again, remember, x does have an exponent. Even though we don't see it, it's being raised to a power. And you need to add together all of the exponents of any variable in a single term. So hopefully you guys are all figuring out the degree to that term would be 3. Our next term, we have 4a squared bc cubed. We don't care about the 4. We care about the a being squared, the b being raised to the first, and the c being raised to the third. This monomial has a degree of 6. And then lastly, the degree of the constant, negative 23. This one's a little bit tricky, right? Because we don't see a variable. But if we were to see a variable, what power would it be raised to? All right, so this last monomial, this constant, negative 23, has a degree of 0. And in fact, any constant would have a degree of 0, right? Because there are no variables attached. All right, so a polynomial then would be when you have 2 or more monomials coming together. And by coming together, I mean a sum, right? So we are now going to start seeing pluses and minuses to indicate that you're adding or subtracting these monomials. So a polynomial just means you have 2 or more monomials together. But just like with polygons, when you guys learn some of the key polygons, right? Polygon is just a generic term for a multi-sided, close-shaped figure. But like a 3-sided polygon, we call a triangle, right? So polynomials also have some special names. If there are 3 terms, just like if there were 3 sides of a polygon, we would call that a trinomial. If there's only 2 terms, we call it a binomial. So those are 2 words I threw in here because I'm guessing you have heard those before. The examples below, the one on the left is an example of a trinomial, and the example on the right is a binomial. And again, it can be kind of helpful to use those pluses and minuses. They sort of help separate your terms, right? Because remember, a single monomial is multiplication only, so it's everything all jammed together. All right, now this next page, I'm pretty sure you guys already know this. I just wanted to take advantage and take a moment to remind you that every monomial, each term in a polynomial includes a coefficient, a variable, and an exponent, right? You might not always see all those parts, but each monomial does have those parts to it, right? So in this particular trinomial, I tried to do some color coding. So red would represent the coefficients, right? The first term has a coefficient of 5. The middle term, even though I just made the 3 red, really I should have made the subtraction sign a red as well, because this is what I meant by the sign that precedes the term is really a part of that term, right? So even though that's a minus 3x, that's the same as adding a negative 3x. And so it's going to be easier for us just to think of that as a negative 3 coefficient, the variable being x, the exponent in that particular case being 1, right? When you don't see an exponent next to the variable, that means there's just a exponent of 1 there. Okay, so just wanted to throw that in there. Okay, polynomials like to be written in standard form. And standard form means that you have the terms arranged in decreasing order from largest degree to smallest degree, okay? So here we have an example, 5x plus 2 minus 3x squared. That is currently not in standard form because can you see underneath each of those 3 terms, I've noted the degree, right? 5x has a degree of 1. That plus 2, that has a degree of 0 because there's no variable at all. And this last term here, this negative 3x squared, has a degree of 2. For this to be in standard form, we need to lead with our highest degree term, right? So that negative 3x squared should go first, making sure that you remember the reminder from the previous slide that the sign that precedes the term stays with the term. So that's a negative 3x squared, whether it's written last or first, okay? So I haven't changed anything with this polynomial other than just rearranging the terms so that it is in what's called standard form, okay? That's all that is. And then this note on the bottom, this isn't super important. I just threw this in here because I know a lot of you like to get hung up on some of these little details. if you find yourself in a situation where here we have a trinomial and each of these three terms has a degree of 2, right? That is a degree of 2. The negative 4xy has a degree of 2 because both the x and the y are being raised to the first power, and the y squared has a degree of 2. So because they each have the same degree, you might not know what order to put them in, right? From largest to smallest. And if that ever happens, you just should go with the alphabet. So because x comes before y, x is what's going to determine the order here. So I go with x squared followed by x to the first, x to the 0. Okay, so again, not super important, just more of a interesting tidbit. All right, last new piece of information here before we bring it all together for naming is that degree of a polynomial is a little different from degree of a monomial, although they're related. To find the degree of a polynomial, you just are interested in the highest degree of any of its terms, of its monomials, right? So if the polynomial is written in standard form, then that means all you have to do is focus on that very first term. So in this first example, 2x squared plus 7x plus 4, it's in standard form. So I only have to look at that first term, 2x squared. I see that it has a degree of 2, which means the entire polynomial has a degree of 2, all right? This next binomial, also written in standard form, the first term has a degree of 1, which means the entire polynomial has a degree of 1. And then this monomial, I just threw this in here to remind you, excuse me, to remind you that with monomials, when you're finding the degree of a monomial, you have to add any variables that are part of that term. So this would have a degree of 4. If this monomial were part of a polynomial, the entire polynomial would have a degree of 4. Okay? So the reason we had to talk about a degree of a polynomial, as far in addition to what is a polynomial, is that polynomials have a certain way of naming them that, just like many people, involves you've got a first name and a second name. So the first name is all about what the degree of that polynomial is. Okay? So if the polynomial has a degree of 2, let's look here in this third line here, okay? So 2x squared minus 5x minus 8. That entire polynomial has a degree of 2, right? Because its highest degree of any single monomial is 2. And so that means that this polynomial is referred to as a quadratic, okay? We've started doing some work with quadratics, but a lot of our work this year and all of 7th grade was with linear relationships, right? That should sound familiar to you guys. That's because all of our work was with polynomials that involved, they were linear polynomials. So they all had a degree of 1 or a variable being raised to the first power, okay? If you were dealing with a polynomial that had a degree of 3, we would call that a cubic. If it had a degree of 4, quartic. If it has a degree of 5, we call that quintic. Now, I'm never going to test you on these, but I do think it's nice for you to know these 6 names, mostly because I'm guessing you already knew 3 or 4 of them. So I think it'd be nice for you to know quartic and quintic. You will probably need them for the homework I'm going to give you, but I just think it's good for you guys to be exposed to it. I won't ask you on a test to come up with this, but I think it's good for you to be exposed to it. You can always refer to a polynomial just in the nth degree. So in other words, I could look at this 7x to the 4th plus 2x squared minus 9 and call it a 4th degree polynomial, but it's just nicer if you know that it's a quartic, okay? So nth degree, that just simply means that any degree, if it were, a 7th degree polynomial, you can just refer to it as a 7th degree polynomial, okay? So that's half of a polynomial's name is the degree. The other half of a polynomial's name comes from how many terms it has. And so again here, we've already talked about a lot of them, and so the only really new one here that I'm asking you guys to familiarize yourself with is if there are 4 terms, we would call that a quadrinomial. Okay, so monomial if only 1 term, binomial if 2, trinomial if 3, quadrinomial if 4, and then if there are 5 or more terms, you can simply say, you know, it's a 6-term or a 5-term polynomial. You don't have to actually know the fancy name for it. Okay, so this is what we're going to practice now. We're going to go through a few examples, and then I'm going to send you a Google form where I want you guys to name 5 polynomials on your own. So you may want to go back over these notes and print off the naming pages I just went over with you. But I'm going to first just give you some examples of what I'm expecting you to do with the homework. So this first polynomial, I see that there are 2 terms, right? The 2x and the -8. That makes it a binomial. And because the highest degree here is 1, it's a linear binomial. For some reason, even though we say the degree first, I tend to focus on number of terms first. So in the second example, it's a monomial, right? There's only 1 term, and its degree is 2, so it's a quadratic monomial. Our next example has 3 distinct terms, which make it a trinomial, but the highest degree is 4, so the polynomial, the entire trinomial, is a quartic trinomial. And then my last example for you has 2 terms making it a binomial. Highest degree is 3, so it's a cubic binomial. Okay? So again, I'm going to send you all of these slides. I'm also going to send you a copy for your first part of your homework. You have 2 parts of homework tonight, but the polynomials naming, I'm going to send you a Google form. I want you to give me the names of these 5 polynomials and submit to me so I see that you understand what you're doing with naming of polynomials. All right. Good luck.